All right, everybody. Welcome to IETF 125 DTN Working Group. Just a reminder that well, a few things. One is my apologies. My camera is currently not working, so you get to see me as just a large gray circle at the moment. This is the first of two DTN working group sessions. This is session one, which will be an hour now, and then we'll have session two later in IETF, which will be an hour and a half. I would like to apologize. Neither Rick nor I were able to travel for this IETF, so we are both running this meeting remotely, but we think things will go smoothly otherwise. And I did want to take a moment and just kick things off. Rick, do you want to go through the working group chair slides, or should I do that? All right, I can certainly start those. A couple of things. Number one is this meeting is being recorded. This is, I think, the first day or so of IETF, so we'll go through these in a little more detail. Please note well all of our typical IETF policies, in particular, the policies related to guidelines for conduct and anti-harassment. Excuse me. And additionally, make sure that we follow all of the BCP 54, which says that we would like to expend respect and courtesy to our colleagues at all times. We want to make sure that we will have discussions related to the technologies and not to individuals. And we want to make sure that we're working on solutions that are really going to work for everyone as we go forward. If you are in the room, please make sure that you are logged in. Please use the on-site tool. And if you come to the mic, please make sure that you announce who you are. If you are not at the mic, please make sure that your audio is off so that we don't have interruptions as we go through the rest of the session. The agenda has been posted, and we're going to talk about it in just a moment. I would like to ask if people would be willing to jump onto the shared notepad and keep notes as we go. We tend to need, obviously, at least one person who can help us take notes, but the more, the better. And we've had a really good participation in note-taking over the past several IETFs. Please take a moment and consider jumping over to the notepad and helping us track our progress. Otherwise, this is the introduction, and note well for where we are in the working group. And then the topics for discussion that we have today are encapsulation of OpenFlow over DTN using bundle protocol. Brian Sipos has a variety of documents that have been progressing through the working group, and he's going to give a report out on those. We're going to talk about an update to BTPU and then an update on DTN reliability with remaining time for open mic. Before we roll into all of that, just wanted to ask, are there any additions or agenda bashings for this particular agenda for session one? I do think that there is one quick agenda item added before we go into that, into the technical content, which is I see Eric Klein is here. Eric is our responsible AD, but I know that we are getting a new responsible AD. Eric, did you want to take a moment and introduce our new AD?
Yeah, it's Tommy. I can't see. I don't know how to see pictures. Ah, good. There he is. Yeah. So it's been my pleasure to try to be a responsible AD for the past 2 years. Thanks for bearing with. And on Wednesday, I'll be stepping down, and Tommy is incoming AD responsible for DTN. So welcome, Tommy, and we'll all be here to help explain DTN stuff and get you up to speed, however we can.
Really appreciate it. Looking forward to supporting everyone and making sure that you all are unblocked and can publish what you need to.
Oh, that sounds fantastic. Yes, thank you. And Tommy, it's nice to see you in person. My apologies that my camera isn't working. That actually might be the kindest thing I can do all day today is keep my camera off. So with that, let us go forward into our agenda for the day. Let's start with encapsulation of OpenFlow over DTNs using the bundle protocol. And do we have the presenters in the room? Oh, excellent. Thank you.
We do not hear you.
Yeah. Miteko, we've got an audio problem.
Okay.
Oh, there we go. Thank you.
There we go.
My name is Jing Fan, representing Beijing Jiaotong University. Today I will be presentation a work on a consideration of OpenFlow over delay tolerant networking using the bundle protocol, which is documented in our correct draft. Please next. Okay. The agenda, today's agenda covers the problem select architecture overview, encapsulation rules, underporting addressing, and our experimental verification. Next. As we know, OpenFlow enables centralized control by relying software defined networking. Um, by relying controller switch communication. DTN environments similarly also require centralized policy dissemination. Traditional OpenFlow control channels rely on TCP/IP and stable end-to-end and pans. However, DTN lacks such pans. TCP makes the control channels become more unreliable. So this work describes the use of BP, which provides the store and forward communication for and supports the naming, addressing, and transport access HR generates links to carry overflow control message. Next, please. The core challenge we are addressing is that OpenFlow assume stable end-to-end connectivity. DTN violate this as simple. Control message in this environment must tolerate delay and transcription, entertainment links, and no ideal delivery behavior. We focus on three use cases: entertainment connectivity, where control switch links are only available sporadically. Long delay paths such control traffic over select or deep space links, and decreased multiple forwarding, where messages are realized via intermediate DTN nodes. Next. Let's look at architecture overview. Both controller and switch are deployed and DTN nodes. OpenFlow logic runs at the application layer. OpenFlow messages are treated as application data nodes, ADUs. These ADUs are encapsulated into bundles by the BP agent. Core engines levers then mapped these bundles to underlying links via CRAs supporting multiple transport bundles like RTP or TCP. Next. Moving on to encapsulation and delivery rules, start with the encapsulation over layer. OpenFlow ceilings are carried as BP payloads. OpenFlow messages are treated as ADUs, and these ADUs are encapsulated into bundles by the BP agent. Encapsulation includes underlying carrier headers, BP primary block, and option extension blocks. And bundle payloads containing OpenFlow ceiling data. BP may operate over different CRAs, and no special tunneling protocol is defined or required. We enforce one-to-one message mapping proof. Each bundle carries one OpenFlow message and are created in their native font. There is and treated as opaque data. There is no message aggregation, analyze, defined, and aggregated. Next. Bundle fragmentation may be used if supported by BP. It must not be used if do not fragment is indicated and animal source is used. Fragments must be fully reassembled and partial overflow message must not be exposed. Do not assume interactive request response timing. Because duplicate delivering and recording may occur, OpenFlow processing must tolerate them. To handle this, receivers should maintain a bounded duplicate cache using source and timestamp. Since arrive order does not flagged send order, use OpenFlow transaction identifier and sequence numbers. Finally, each bundle must have a finite left time and expired overflow message must not be applied. Next, please. To achieve routing, OpenFlow controls and switches are identified by stable Unicode BP EIDs payload delivered to the local OpenFlow entity based on EID. The communication is bidirectional, including control instruction and telemetry. Next. We explicitly varied the architecture by building a prototype based on LNDTN. We successfully carried OpenFlow messages over BP in select terrorist scenario, fitting long deep intermittent connectivity and store and forward message delivery. This varied the feasibility of OpenFlow signaling, confirming encapsulation and delivery schematics. There is no any modification required to OpenFlow protocol. Next, please. Finally, regarding security, the draft does not modify the OpenFlow or BP security properties because DTN stop and forwarding may encroach data exploring. We strongly recommend that deployment should use the exciting BP security mechanism. Next, thank you. I would be very happy to take any question or comments at this time.
Well, I would just jump in and say thank you very much for that, and my apologies for not saying earlier that because we don't have someone in the room, I will need to flip the slides because we don't have a laptop to plug the slide advancer in. But I did not otherwise have a question. Rick, I see you in the queue.
Thank you. Yeah, so first of all, thank you very much for this presentation. I read the draft with interest. Can I commend you on what I think is the correct way to take a standard layer 7 application protocol? Can you hear me? Quick audio check there. 1, 2, 3.
Yes, we can hear
Good.
you online.
Okay, can you hear me in the room? Yes, I see a thumbs up. Great. Yeah, so thank you very much for doing this. I think you've done the right thing, which is understanding the OpenFlow PDUs and mapping them directly as an ADU within bundle protocol. That is absolutely the right way to do it. I know other people, when presented with the problem of how to port a traditional IP protocol onto BP have done some odd things with capturing IP packets and things like that. So thank you. I think this is really the right approach, particularly when you're doing OpenFlow, and good to see that you have some experimental results. Thanks.
All right. Thank you very much. Our next presentation is going to be, or discussion is going to be with Brian Sipos. Brian, would you like me to project and flip slides, or would you like to share your screen instead?
I will try to get the slides. I may have to be granted permission. Thank you.
Sure.
And on the topic of the previous presentation, I also agree with Rick about that draft being a good representation, a good starting point of defining all those details that an application should define. Now, I'm going to cover a few different topics, starting with kind of the most mature and going down to the least mature, with some discussions of last changes and some discussion of next steps on each of these separately. So the first one is going to be the COSE context draft. Next one is EID patterns. Then the non-experimental UDP-CL version 2. And SAND is the last working group draft. And then I have a little presentation about the individual drafts. So on the COSE context, this did complete a working group last call in December. It elicited some good feedback and comments, and this also went through. I'll skip ahead to the last item, that it did go through interoperability testing with 2 separate implementations. So that gave some good evidence of maturity, but also it gave some feedback to the last draft revision. The changes have all been either editorial or clarifying the requirements to agree with what the intent or what the actual implementation is able to achieve. The big set of changes was really in the COSE context, COSE profiling, that added a HKDF algorithm to the interoperability minimum table. And I'll speak to interoperability here means mandatory to understand, not mandatory to use. But it's really focused on what is the minimum that you would expect to need to operate these different types of key materials, symmetric keys and asymmetric keys. The PKIX profile was updated to be consistent with the existing CA browser form. This is not something that's a hard requirement, but it is helpful to be able to say that we're in agreement with what's used in the web PKI and the very, very large existing PKIX ecosystem that we can operate within. And the last set of changes were updating examples to make sure that the example full BPPDUs had conforming CRC values and key strengths that were consistent with the CNSA version 1 minimum, which is being kind of treated as a reasonable minimum security strength as a starting point for the COSE context. The draft now leaves out mentions of future capabilities enabled by COSE, especially post-quantum stuff, but definitely updates or other protocols can raise the interoperability minimum floor to include these other families of algorithms. And then this is just a general comment on the profiling and use of COSE, is that by integrating the COSE message form into BPSec, this opens the door for individual users or networks or combinations of nodes to use whatever algorithms suit their needs. And It just needs to be worked out ahead of time offline what those are. But the interoperability minimum that's presented in a document is meant to be a baseline of what to expect if you don't know any better. And I will mention that at this point, there's not a specific item on this slide. I did make a call on the mailing list that this document, I believe, is ready to leave the working group and enter IESG review. So I can reiterate that on the mailing list, but I'm mentioning it here as well. So this is directed to our new AD that some of these documents have some feedback requested and some have some actions requested.
So just jumping in, chair hat on there, Brian. Yeah, noted. We felt it was useful for you to do this presentation at this meeting, and then we'll probably press the button and get it through to IESG.
Thank you. And the good news is that this interoperability testing that was successfully completed did what interoperability testing I think should. It showed the spots where the letter of the law was a bit weak, and so this last draft really strengthened things up so that the text agrees with what the behavior was and should be.
And Ed, Chair hat on, I believe the status of this document is working group consensus waiting for write-up. So I would like to just take a moment and ask if there is anyone who is also familiar with this work that would agree to be the shepherd for this document. Please let us know, either in a chat or on the mailing list, preferably on the mailing list. Otherwise, we will start asking folks to find someone who would be willing to be a shepherd for the document.
Thanks. So I'll move on to the EID patterns draft, which is slightly less mature than the BPSec COSE context. So this document is meant to provide a framework for patterns on current and future EID schemes and provide an extensible IANA registry of patterns to go along with the existing registry of schemes. And this is focused on text forms and binary forms. And it already has multiple implementations currently in several different languages and different organizations as proof of existence. There are some variations that I'm not going to dig into on this presentation in detail, but it covers details on IPN scheme-specific patterns, but also it enables doing any scheme-specific part patterns for the existing DTN scheme and any other future, including private use schemes. So it's meant to be a starting point, but a starting point that is based in existing use patterns. So the last changes to this document were to add more explicit definitions to some of the terminology, to nail down and tighten up some of the definitions of are you allowed to match nothing? And the answer is yes. Requirements about normalization and elision. And all this means is that, especially in the text form, there are many different possible ways to put things into a piece of text. And this is more clear now about what is the normal form of any of these things. There's an improved binary form for IPN range and a picture to show what this thing means. This is really a compression based on like delta compression. And there's now a couple of extra subsections for security considerations that just relate to where this thing might be used and how it needs to be handled. There's one more open issue on this draft, and that's right now there's not an interoperability minimum support for number of items in one pattern or number of intervals in each IPN element range. I did throw a question on the mailing list without any feedback so far, but I do have some some text drafted and could discuss this separately on the mailing list. But it would be something on the order of 10 as a minimum and a should for something on the order of 100, just as a round number that nobody should be running into as a limit. And go ahead, Rick.
A very quick point on this, particularly on the interoperability. So in our session 2, I've got a short presentation on using a subset of EID patterns to actually exchange routing information between different implementations, which I think might handle your interoperability request, because that's actually a case where you need EID patterns to be interoperable.
Yeah.
The other case being C509 certificates, which could carry EID patterns, but that seems quite a hard interoperability target. But most of the EID patterns otherwise are very much local machine or local implementation specific.
Mhm.
So maybe that will help. And as a note to the working group, I'm trying to build on top of this already. I really like
Great.
this work personally. So yeah, cool. Thank you. I'll shut up.
Thanks. Yep. And that is what interoperability means in this context. It means if I write a pattern that has 6 items, how reasonable is it for me to expect that a system is going to be able to handle that pattern with 6 items? And if the minimum is 10, that means I'm guaranteed that any conforming implementation will handle my pattern properly. And if I start to increase that number, it'll get into that range where maybe some implementations will and some may not. So it's something we can discuss on the mailing list. I do have a draft. I have a proposed update to a draft to address this. And I would like to see a last call either as written with this known issue or after this issue is addressed. If there are any opinions at all, I'd like to hear them. And I can post a link in the mailing list to the proposed changes just to get the exact words in front of the group in the list.
Ed, with chair hat on, if we do have some changes and those changes are not difficult to make in a timely period, I would ask that we make known changes first, because those changes may cause others doing last call reviews to think of additional things. So it's always better, in my opinion, to go in with known changes applied.
So I will put the changes in with like the minimum number of 10 there, although 10 is not a strong justification. It is a round number that is pretty small and easy to implement, hopefully. On the next topic of the UDPCL, there's not a real big set of changes in the document itself. There has been a trial implementation of all the features that are defined here, although there's one of the last changes is a deeper explanation of optional to use. Again, the difference between mandatory to implement, mandatory to know what the code point means versus optional to use any of them. That's now better explained. And one of the things that is part of this optional to use is congestion control in band that I'll discuss in the next slide in a minute. Another one is supporting the existing definition of packetization layer, path MTU discovery. This is not inventing an algorithm. This is providing capability to exercise that algorithm in this packetization layer. And then there's a limited form of some other path characterization that the document discusses in detail. But it's really just things that are operationally useful on networks that you don't necessarily know all the details of, or that can change while they're operating. Some more detailed definitions were added, especially IP reachable. What does that mean? And what do you have to, how does that relate to some of this characterization stuff? It does update the encoding of this CDDL rule to be able to give better compressibility. This is not a change in function, just a change of using a compressed encoding instead of an uncompressed one. Again, there's more specific requirements under a new section 3.8. discussing congestion notification. And there's now an Appendix B added to just explain why or how you would choose a congestion control algorithm and what the implications are. There is a remaining TBA, or 2 of them in this document, related to IP multicast assignments for this purpose. There was a previous request for this. I'll mention it here, and I can reiterate this on the mailing list. And our new AD, this hopefully is not a big lift, but it is something that is remaining in this document to be assigned.
I do see, Eric, your hand is up.
Thank you. Yeah, I was going to ask, how do you envision the multicast working with DTLS?
Not at all. And that is one of the existing considerations that's hopefully described here, is that we're not trying to tackle that specific behavior. The vision here for multicast is purely for a kind of a bare minimum zero configuration sort of messaging, with the known security properties that entails.
Right. Okay. Thank you.
And if there's feedback on the exact wording in the document, that would be great.
I'm just going to jump in at this point with chair hat on. The UDP-CL version 2 is a really important piece of work, because there are a number of UDP-based CLs that have come across from the IETF that are experimental, that do not tackle things like congestion control, are not good citizens on the public internet. This is I don't want to diminish Brian's work on this. This is in some ways a housekeeping exercise to pull together everything that needs to be done in order to get a UDP-CL that actually works and is fit for purpose. So I really commend to the working group to read this document. We need to get this done. It would be really useful to get this into the IESGQ and properly standardized promptly before people start building more and more implementations on top of the previous generation of UDP-CLs.
And that is a good and important point, that these things that are extensions here are, as Rick said, they are aspects of being a good citizen on a larger network. And that is why they are all optional to use. And hopefully the document explains when you would need to or want to make use of them. I have one other piece of information on this UDP-CL, which is I did run a little congestion control experiment as a kind of a proof of concept using very off-the-shelf, not complicated test setup, but I did artificially limit a link using ECN markings, and didn't want to or need to or bother to try to simulate additional path effects. But the result is, as you can see in this somewhat small graph, is it did the right thing. It reached congestion control at its assigned limit. And one thing that's not in this plot is this resulted in 0 packet drops, which is great, because this is an unacknowledged protocol. So every packet drop is also a bundle failure to forward. But this is demonstration of you can do congestion control in a friendly way. I chose a CCA that had a very straightforward implementation, but there's no restriction here of any operator choosing any CCA to use for any situation that is friendly in their environment. And the one I chose was one of these aggressive data center type ones. So this is meant to operate into very high rates. And I would love to see some other experiments in this kind of realm. My time is running out, so I'll give a real brief discussion that the secure advertisement and neighborhood discovery SAND is still being worked, although there have not been recent changes here. It's settled out pretty well. That here I'm addressing Eric's question about what is the point of the UDP-CL multicast, and that is, when being used with this kind of an application, it enables that zero configuration discovery. It enables a blind way for an advertisement to take place and a zero configuration way for that to be received. So it's that kind of bootstrapping the completely unknown situation. The capabilities of advertising are shown here, and I'm not going to get into details because I do want to cover very briefly one new topic, which is, let's skip past this a bit. The manifest block. That is a new thing. I did give a real brief explanation on the mailing list, but I do want to mention that it is a thing that now has an initial definition, and the later session of this working group is going to present a security reason code that would make use of this manifest block. And so this is just a really simple explanation that the thing is here. It allows you to record at a node the blocks that existed at the time the manifest was created. And that means maybe blocks that were removed later on down the path or by that very same node. So I think this is a pretty straightforward starting point. But again, I'd like to receive any feedback and in relation to that other draft. So thanks for the time.
Just Ed, with chair hat on, I really support a manifest block structure. We've talked about it for years. I think we're getting to the point where we know how we would like it to see, why it will be beneficial for security. So if we can get more discussion about this on the mailing list as well, it would be appreciated. But a manifest block, in my opinion, is a great idea. So thank you so much.
Yep, and this is individual draft. This is just a starting point. So feedback is very welcome.
All right. If there are no other questions, then our next presenter will be Rick for BTPU updates. Rick, would you like me to flip slides or would you like to share the screen?
Can you bring up the slides, because I'm struggling with Meet Echo and early morning starts. And while you find that, I will apologize for the cage in the background.
There
That
seem
is
to be
actually
some people in the queue.
yeah, Q. Let's handle
Oh,
the
I did
queue.
not see that. Please, yes, let's go back. Tony.
Yeah, this is Feng Yang from China Mobile. One question about that presentation is, DTN is has quite long latency between the different hops. So the question is, how can we tell if the traffic drop is based on the congestion or non-congestion? Thank you.
Sure, I can answer that very simply by saying the UDPCL is completely unacknowledged. And so there is no intrinsic feedback mechanism to answer the question. Why did something get dropped? We just simply don't address that. But it is an important topic, and please let me know on the mailing list if there's any language that makes sense to better explain that. Thank you.
Okay,
We have Tony as well. Tony, go ahead.
No, that was Tony, and then I think our next speaker up.
That was Fang.
Yep.
I'm Tony. Hi, I'm Tony from Y Project in Japan and a member of IPN-SIG. So I had a question regarding Site 6, where you talked about UDP-CL v2 using proc CCA. And my question is that since proc CCA utilizes high frequency ECN feedbacks to maintain stable throughput, is there any some sort of predictable, how can you achieve predictable performance in high RTT environments like space? And also, is there any mathematically defined boundary, stability boundary for RTT when congestion control loops diverges? Yeah, that's my question.
I think that, yeah, that's a really good question and an important topic. The use of a CCA in this case was really meant to show that the CL would operate in the other extreme environment of data center type situation. So that was the reason for using prog, is to say, here is a CCA that operates in a high throughput data center environment. can we achieve these kinds of operating environments in a way that doesn't overwhelm other flows.
Right.
So that was not trying to address the long RTT situation, and you're absolutely right that is definitely a consideration that at some point you would not want to use congestion control.
Thank you.
Just to jump back in, the Ed with chair hat off. One, Tony, I'm sorry that I did not see you as Tony. But the other is to Brian's point. When BP is used, we expect it to be end to end, to include segments of the network that don't have the same RTT issues as we would expect on the longer delay segments. And so I would imagine that UDP CL selection or certain CL selection is going to be based on the characteristic of the segments carrying the bundle, and that there would be cases where just certain CLAs are not going to be used for those reasons. So I think it's important to note what the characteristics are, but I don't think we should, but other than saying these are the limitations, I don't think we have to try and make things like the CLAs work in each environment.
Thanks, Ed. Which brings me nicely on to talking about BTPU. So again, this is another convergence layer protocol that's designed for specific segments. Let me see if I can make the slide clicker thing work through. Can I grab control of this? How do I request control? No, Ed, you might have to move slides for me. I can't. There we go. I have control. Excellent. Let me click. There we go. So I'm just going to start with a very quick recap and then talk through the changes that have been made since the previous versions of the draft. So again, convergence layer protocol designed for unidirectional, unreliable frame-based link layers. So some examples of that are the CCSDS suite of USLP, TM, AOS, and all who sail in her. Also DVB-S2X, 5G PDUs, and Ethernet. So these are all lossy frame-based link layer protocols, which can handle a single logical segment. Okay. Unlike some of the other previous protocols that have come around, this has segmentation of bundles across link layer PDUs. It looks a lot like TCP-CL and UDP-CL in that way. But it also allows the interleaving of transfers so that you can avoid head-of-line blocking. It has message repetition, allowing loss protection because, and the clue is in the name, this is a unidirectional service. So there is no return path for acknowledgement. There is no send and ACK. There is no round trip. It is simply unidirectional. Blast it and assume that the other end gets it and repeat if you want to increase the likelihood of that happening. Fundamental construction of the whole thing is TLV. So it's designed for line rate, hardware, software, FPGA. They kind of like TLVs. And the other important fact is, unlike UDP-CL and TCP-CL and QuickCLs that are starting to emerge for terrestrial delivery of bundle, this does not require an IP stack. So you can go straight down to whatever frame layer your optical inter-satellite links are using, which may be Ethernet based, or you can pack it straight onto your legacy DVB or use your deep space CCSDS link layer without requiring a full IP stack, particularly useful for future spacecraft architectures, etc. So I've kind of summarized this. The other main advantage of it is I can see how it would replace things like LTP in some cases. Because LTP has the red and the green flavors, for those who know it, it has a state machine which requires a bidirectional link layer, which requires sort of EPP for those who know the CCSDS specifications, which then sits on top of the framing layer. If you're using BTPU, you can set up 2 unidirectional BTPU links that sit straight on top of AOS and SLE, which will allow you to massively reduce your stack and massively reduce your complexity, therefore increasing, it's a better fit for swap, size, weight, and power, and it is you should be able to get some slightly better throughput and get some hardware acceleration. These are statements that are open to challenge, and I welcome people challenging those assumptions. So things that have changed. I made a change in the last draft before this one to have descending segment indexes because it seemed like a nice feature to be able to understand how many segments were going to arrive so you could pre-allocate buffers. This had a problem, which was the sender could not be so flexible with its sending rate, so it had to decide how many segments to send at the beginning upfront rather than being a bit more rate controlled. This was pointed out to me was a dumb idea, so I switched it back round to the much more traditional start at segment index 0 and count up and have an explicit this was the last segment marker. It's much more rational. I don't know what I was doing before and I can only apologize. That's the main change here. I'm going to blast through fast. I don't have a lot of time. Because of that change, I've had to rename some of the message types. They're no longer called start and segment. They're now called segment and end because you now mark the final segment rather than the first one. To answer Jorge's question, and this is a CCSDS specific thing, if you use AOS without EPP, how can you tell the payload is a bundle? You just have to use the virtual channel identifiers. So that's actually, sorry, I'm going to stop based on that question. There are some assumptions that are written at the top of the document. BTPU is a generic way to slice up a bundle and carry it over a link layer. How it actually maps a particular virtual channel, start and end, source and dest pairing or whatever has to be determined by the exact mapping of BTPU to the underlying link layer. And in session 2, Eric Klein will be presenting how to run BTPU over Ethernet, and that is a good demonstration of a document which says, take BTPU, here are the missing pieces to make it make sense under Ethernet. So, for example, if you want to run BTPU direct over USLP or AOS, there are some considerations such as virtual channel identifiers or protocol types that you need in the underlying link layer to demux effectively. So, other changes, and I know I'm going fast, I can only apologize. I have renamed metadata items to hint items because the name metadata was confusing. Basically, it is a side channel where a sender can add useful information that the receiver, well, information it thinks is useful for the receiver. So the receiver can pull out the good example that is worked up at the moment is the total size of the bundle is X. And then that can be included in a number of the messages throughout the total transmission so that the receiver can pre-allocate buffers or do something smart. A second extension to this is if you are running 2 BTPU sessions, one from source to dest and a paired one coming back the other way, you can include a hint item, which is some sort of cookie to say this unidirectional session is actually the return path for that unidirectional session. And this is, of course, entirely sender and receiver specific, but a cookie could be exchanged, therefore allowing some sort of logical link between the two fundamentally unidirectional links. That's quite useful for people who want to do transfer cancel, etc. But I'll come into that in more detail probably at the next meeting or take it to the mailing list. What else have we got? Yeah, so hints can now be chained. Very much like IP headers, the ability to say, I have lots of hints. How many hints have I got? And when does the actual data payload lift? When does the actual payload of the message start? This is pretty standard technology. I haven't invented anything new. You mark hints, and the last hint has no hint follows. Pretty simple stuff. I've cleaned up the RFC keywords because there were lots of mays and musts that should have been capitalized and shouldn't have been capitalized. Okay, I've also put a little bit of extra text to explain why there is a transfer window and the purpose of it. And the point of the transfer window is so that a listener can start listening, a receiver can just start listening to a stream and understand whether it is hearing segments which make no sense to it because it has been asleep when it wasn't planned to be asleep or it has missed a lot of transmission, and how to understand how many of the transfers that are in progress are valid and how many are repetitions or overhearing or something that is outside the scope of the session it is trying to receive. So this is a way of passively synchronizing a sender and a receiver without having a path from the receiver back to the sender to say, I have acknowledged. It's a lot like the kind of processes that happen in Raptor codes or Tornado codes or Fountain codes, so that you can have a receive-only device still be able to receive in a reasonably reliable manner. And this has a rolling window with a applicable, that has a rolling transfer count with an applicable transfer window that captures the ability to say that is too old, or the window has moved forwards, or that is garbage. Please check the details in the document. It's mildly complicated, but there for a very good reason. Yeah, IANA registry updates because I've fiddled with some message codes. Yeah, sorted out some minor typos. And so some open questions for the working group. I have picked an arbitrary number for the recommended value of the transfer window size because, like all good IETF specifications, you should recommend a default value for any tunable parameter. I picked 16 because it sounds nice. I have no empirical evidence over whether this is a good value or a bad value. I'm looking forward to somebody implementing this apart from my scruffy little sort of vibe coded stuff, and try and work out whether 16 is a good number or whether we should recommend a much bigger one or a much smaller number. You've got a maximum size of 2 to the power of 12 due to the rollover mechanism. I'm also looking for more feedback on the hints mechanism. I have received some feedback on GitHub, which was really nice, and I'm looking for more people to give me some feedback on that. Because I've updated BTPU, there is a parallel companion document called BTPU FEC, which allows you to do forward error correction or on top of BTPU messages. And that absolutely leverages the FEC framework, which is RFC 6363. So I am not inventing FEC. I'm literally porting an existing IETF FEC framework to sit on top of BTPU. And I have literally done an editorial pass, having made changes to BTPU to correct the statements in the FEC document, and that's resulted in another uprev. IANA, grammar, updated security considerations to make it absolutely clear that there is no security at the link layer, or if there is, it is out of scope of this document. You should be using BPSec if you care about security. That's properly drawn out. I've also a little bit of semantic changes. I had overloaded words that meant something in the FEC frame document and also meant something in the BTPU document, just aligned those so it's a bit more readable for people familiar with one or the other. And that's it. So, I'm interested in working group feedback on the open issues. I'm looking for more people to read it, and I'm looking for more people to implement. This is a working group document. I don't think it's ready for last call. I would like more people to implement and bash it harder. But I think the specification is pretty stable, but until we implement it, we don't really know whether it's correct. And that's all I have to say. I will take any questions. I'm just watching the chat, actually. Eric Klein, do you want to take that question to the mic?
Sure. Yeah, my guess is that whichever transfer window size is selected by the document, there will always be a better value on a per deployment and per link type adaptation basis. So
completely agree.
It's
yeah,
possible. Just roll a d20 and pick a value.
Yeah, and I rolled 16. And it is really that. It may be the conclusion of the working group that 16 seems a sensible number, and every single deployment goes out and tunes it properly.
All right. In the interest of time, let's go to our last topic. We do have about 6 minutes remaining. And the last topic is an important one, but too important to cover completely in 5 minutes. So I'm going to give a very brief overview here and then start taking some of the questions to the mailing list. As some of you may remember from the last IETF, we started presenting discussion around the distinction between custody transfer and reliability. So without going deeply into it, for those who are tracking bundle protocol from BPv6, there was a formal method for custodial transfer, and that was removed from BPv7 with the idea that it would be subsumed with additional reliability discussions. And as we started working through that, we came to understand that there were probably multiple ways of discussing custody and custodial behaviors against reliability objectives. And the DTN reliability informational draft talks about this is a function of multiple layers working together. We talked before about things like congestion control in the UDP convergence layer and so on, that sometimes if it's available, you can use it. If it's not available, you shouldn't use it. But what reliability can we put at the bundle layer? In the previous version of the document, and a -01 is forthcoming to this, we had hypothesized 4 classes of reliability, from no reliability to redundant custodians. We've expanded that thinking based on discussion since the last IETF to say that there is a level of reliability class 1, which says we actually don't need any. It's best effort. If you get it, you get it. Class 2, which is the default behavior of RFC 9171, is to store a bundle until it is ready to be transmitted. And we have termed that as store until forward. And then class 3 is a, pardon me for a minute, on the chat, Adam, are you able to see my slides? Okay, others can.
I think it's an Adam only problem.
Okay. Class 3 is a guaranteed custodian, meaning somewhere along a path there will be at least one custodian made available for your traffic, and possibly that is a path selection criteria. And path 4 is that you may have multiple paths, with each of them having different, with each path having independent custodians. And the idea behind some of this reasoning is that in class 3, which is shown on the left with the sample network with the user source and destination across the network, individual network segments or network providers may choose to have 1, 2, 4 custodians as part of the services they provide. The end use, the user source and the user destination may not always know the way in which custodial networks are deployed through the network, but they can say things like, I want class 3 service. I'm going to hold on to my data until someone tells me that custody has been taken. Or in class 4, I'm going to hold on to my data until I get 2 independent custodians for my data, or something like that. But we then ask the question, what is custody signaling actually accomplishing? And this is sort of the heart of the discussion. Are we signaling custody, meaning that another bundle agent is going to store the bundle for us, and therefore we can remove the bundle from our own storage? Or are we signaling reliability, meaning that a network or a network segment is going to agree to carry our data? If we say that we're only signaling custody, then that implies a node-to-node relationship, which may break information hiding across service providers. And so if you were to have a case where a user was talking to, say, a network that's a transit network for them, and that network were to put a custodian at the edge node, the user might expect that since the edge node is the thing that gave them a custody signal, that same edge node would be doing all of the storage and retransmission, which is probably unlikely that a single edge node would do all storage for all traffic coming through their network. It is more likely that at an edge node, a network itself would signal a reliability capture, and not otherwise lock down that reliability to a particular node in the interior of a network. And so we're trying in this draft to address this difference between expressing reliability requirements separate from node-to-node behaviors that may cross network boundaries. So there were a couple of brief questions here, which we will put to the mailing list. One is, do we agree that store until forward is a better distinction for RFC 9171's default non-custodial behaviors? The second is, a second is a side discussion, which in the interest of time we can't completely get into, is whether there's a special case of a destination itself accepting custody if it can't attach to a downstream application immediately. And then the larger question of, should we be talking about custody transfer and custodians, or should we be talking about the idea that a custody signal says some node within the network will serve as a custodian, in which case we start signaling reliability as opposed to node-to-node custody signaling, which is sort of a lot of things that we don't have a lot of time to get into just based on where we are now, because we're at the end of session 1. But please, if you are interested in this, when these come up to the mailing list, please participate in the conversation, and thank you.
Thank you very much, Ed. I believe we are at the very close, if not the close, of session 1. that I see no questions in the queue. So thank you very much, everybody. Thank you for people dialing in from random time zones, and thank you for everyone in the room and the presenters. We'll look forward to seeing you tomorrow at roughly the same time, I believe it is. And we have a longer session. Please give us feedback on the list between now and the end of IETF week about whether the 2-session format is working for you. And otherwise, I will say thank you very much and thank you for your attendance. Session over.
Thank you, everybody.
Cheers all.